Welcome back and welcome to section 2, where we're going to look at how to integrate Lambda with a database. So there are only two parts or two videos to this section. First of all, we're going to have a brief introduction to DynamoDB. If you've been following this course from the beginning, you'll already know what DynamoDB is, so this is going to serve as a brief reminder. And then we're going to jump right into a hands-on demo where we're going to use the Serverless framework to manage a DynamoDB table and write some simple JavaScript to write data into that DynamoDB table as well as to query it. Welcome to this video, DynamoDB, a reminder. In this video, we're going to take a look at DynamoDB as a NoSQL technology and just have a brief reminder of what NoSQL means, what a document store is, and some of the basic features and technologies that DynamoDB offers as a service and how and when we should use them. So what is DynamoDB? Well, DynamoDB is a fast, scalable, and fully managed NoSQL database service. So you can think of it as a serverless database, or database as a service. DynamoDB is a NoSQL database, and it supports both the key value and document storage models. And we'll see a little bit what a typical data structure in a DynamoDB table looks like in a few slides' time. DynamoDB is suitable for a huge range of use cases, but particularly for web, mobile, gaming, IoT, and other applications that need consistent latency. And this is perhaps the biggest strength of DynamoDB. Because it's serverless and because it's a database as a service, it offers consistent read and consistent write latency for all of your applications. You don't need to manage servers, you don't need to manage indexes, disks, etc. All you have to do is provision read and write throughput against a given table, and Amazon takes care of the rest. So DynamoDB has a couple of data fundamentals. Firstly, and as we've mentioned, we have tables. And a table is exactly the same concept as in a relational database. It's just a collection of related data. And within each table, you have items. And these items are simply individual entries into your table. You can think of them like rows. And lastly, we have attributes, which are the properties associated with each of these entries, essentially like a column in a relational database. The difference is here, in DynamoDB, an item always has to have a primary key. You can think of it a little bit more like a hash map than a relational database, in that every item has a key and the value can be anything which is made up of a number of attributes. So with DynamoDB, you have to provision throughput ahead of time. And there are two types of throughput, both for reading and for writing. Now, you can update this at any time, it's flexible, and your throughput updates in real time without any downtime to your table. However, do be aware that it does take some time to re-provision throughput against a DynamoDB table, although you can now, as of a fairly recent update, actually auto-scale your read and write throughput against your DynamoDB table. Nonetheless, this does require a little bit of capacity planning, since if you exceed your provisioned read and write throughput, read and writes against your table will actually start to fail. And although again, as you can auto-scale it, it does take some time, sometimes even a number of minutes, to increase either your read or your write throughput. So this means potentially your application could actually be failing and your reads and writes could be timing out while your capacity is increasing. So do consider capacity planning ahead of time. So in terms of data model, this is a simple example of what a movie table might look like. And we've got title, year, rating, etc. And this shows two different documents. So in this example, the title could be the primary key. That has to be unique, and that's what we reference on. And then these are just attributes to that object, to that entry. And we've got two different objects here. And the best way to think about the DynamoDB data structure really is as a JSON document. You have a key, and you have values and attributes. And one of the nice things and one of the really powerful things about DynamoDB is documents can have nested fields. So we can see here we have an extra info attribute which has some additional fields inside them, and those fields can be arrays, strings, numbers, pretty much any data type you like. So as I mentioned before, one attribute has to be the primary key, and it's called the partition key or the hash attribute. And under the hood, Amazon uses this for distributing your table across multiple servers, but it's very, very important that it's unique within your table. That's something that DynamoDB enforces. Now you can actually have a composite primary key, which is two attributes. That's one option you have. And typically this is made of a partition key, which is the hash key, and a sort key or range key. And this can be very powerful when using these keys to query and order your data. So you can have items with the same partition key, but their sort or range key must be different. So if you use a composite key, those two things must uniquely reference an individual entry in the table. One of the most powerful features about DynamoDB is the option to enable streams. So you can think of this a little bit like a trigger against a traditional relational database. And what DynamoDB Streams does is record data modification events to DynamoDB tables. This data is stored in a log for up to 24 hours in near real time, and for every create, update, delete of an item in the table, DynamoDB Streams writes to a stream record with the primary key attributes of that item along with what's happened to it. So if you want to simulate a trigger against your table, you can actually subscribe a Lambda function to this stream and perform an action for each create, update or delete against your table.